Alrighty, we're here with a test for review. Start things off. We're in the exact same system. Wait, I need to pick a new color. Alright, we start with the exact same system of equations for everything, which is going to be x plus 4y equals 3 and 2x minus 7y equals negative 24. He also immediately tells us that x and y are equal to negative 5 and 2. The first one is just going to ask you for elimination, as in get x and y using elimination in system of, or not elimination, I think it's substitution actually. Alrighty. Essentially, I need to pull my notebook for this. Let's see here. Oh, to our page. So, we're going to start out by isolating this x. Let me get it green. Start by isolating this x. X is equal to negative 4y plus 3. You can substitute this into here now, and you will get 2 negative 4y plus 3 minus 7y is equal to negative 24. From here, you'll distribute. That will get you negative 8y plus 6 minus 7y equals to negative 24. If you combine things properly and subtract the 6, you'll get negative 15y is equal to negative 30. Y is going to be equal to 2. And that's how you solve the first one. Checks out right here. Then you can go back and substitute the y in for x up here. And that'll be, it's going to be, let's see here, 8 is equal to 3 plus x. Just subtract the 8, you'll get negative 5 is equal to x. Next up, this is problem 2. It's substitution, or it's using addition or subtraction, elimination. What we're gonna immediately do is we're gonna write out the new, or this exact same system. So let me, I don't know what color I used. I'm gonna use red because it looks nice. We're gonna use x plus 4y is equal to 3. And then, let's see here, 2x minus 7y is equal to negative 24. In order to use addition or subtraction, you have to multiply equations. So what we're going to do, we're going to multiply this by 2, negative, I think, right? Yeah, negative 2, because we want to get rid of this x right here, so we can just have a solo y value. So that'll make it negative 2x minus 8y is equal to negative 6. You're basically just going to splash this equation into this one. Just combine all the results. And what that will get you is negative 15y is equal to negative 30. Holy cow, y is equal to 2. And then you can just go back and replug this in to the original values, and that'll give you negative 5 as well. The main showstopper of this test is the stuff with the matrices. And it's actually pretty simple once you get the hang of it. So what we have to do right away, let's write it out again. So x plus 4y is equal to 3, and then 2x minus 7y is equal to negative 24. We're doing something called an augmented matrix here. Essentially what that is we're going to write these big brackets, and all of these things have a value to them. I'll highlight them all. This right here is a 1. So what we're going to do is we're going to write down all the values. So 1 is here, 4, 2, negative 7, We're gonna draw these two dots to like indicate the equal sign. It's gonna be 3 and -24. Um, I'm not so sure if these dots right here have any actual value to them, like any meaning. I frankly don't think they do. So you're chilling if you don't include them. Um, and what you have to do here, if you want to make, in order to get the thing it's asking for, the row echelon form, we want this number to be 1, and we want this number right here to be 1 as well. So we're gonna use some like matrix line equations or whatever they're called. We're gonna make this -7 a 1, and we can frankly ignore everything else because as long as these two things are 1, we've achieved the row echelon form, and that's what we want to get. So in order to start off on that, we're gonna do row 1. This is the row we're gonna be modifying. Wait, no, I lied. I'm a big liar. It's gonna be row 2. This row right here, I'm gonna get a new color. This row is the one we're going to be modifying, which is why it's marked as row 2. Let's check my notes. In order to make this a 1, we're going to have to do a subtraction symbol minus, am I looking at the right thing? I am, okay. 2, row 2. So essentially we're multiplying, or row 1, my bad. We're multiplying this entire equation, or this entire line right here by -2. And what that does is it gives us a beautiful new bottom line of since we really modified the bottom line, by the way, it's top line is gonna stay the exact same, and then row 2, the modified one, -2 applied to 1 is gonna make that -2. Crunch those numbers together, we're gonna get a 0. -2 applied to -4 makes that a -8. -8 and -7 crunched together. -15. Wild. I think you guys see where this is going. We're gonna draw these little dots. -2 applied to 3 makes that -6. -6 crunched into the -24. It's gonna get you -30. We have one more step to do, and that's to make this number, let me get it in red actually, this number equal to 1. So we're just going to do a little bit of insane magic and divide row 2 by, that's not a divide symbol, divide it by 15, -15. And that will give us the result of 1, 4, 3, boring stuff, and then 0, 1, because we divide by -15. -15 divided by -15 is 1. And then -15, or 30 divided by -15 is going to be equal to 2. It looks like no, I did not make a mistake on here. This is the correct answer. This is row echelon form for number 3. And the reason it's row echelon form is because these are both 1s, or like, it's like this diagonal is both 1s. So yippee! I think the dots are the ones that like say on this left side needs to be 1, 1. Anyways, that's question 3 down the drain. If we scroll a little up, we'll start on question 4. And that is to continue the problem from question 3. So I'm going to write out the end result of question 3, which was 1, 4, 0, 1, 3, 2. This is the current row echelon formation. We want to get it to reduced row echelon formation, which is essentially making this left side an inverse, which is basically 1, 0, 0, 1. I don't know why it switched off of white there unless I clicked it. You want to make it look like this. You want to make this left side look like this. And frankly, anything is on the table to make it look like that. Wait, I drew that wrong. There we go. That's the right thing. Sorry if anyone paused at that moment. Um, so what we do from here is it's quite literally just one equation. Row 1, because that's the one we want to modify to make this 4 right here a 0. And we're going to subtract it. We're going to subtract this bottom row by 4, so 402. To make this number right here a -4. And then when we crunch those numbers together, it'll make it a 0. And since this number does not change, since we're only modifying row 1, which will give you the result of 1, 0, 0, 1. And then -4 times 2 is -8. -8 and 3 crunched together, it's going to be -5. It's now -5, and now this just sticks at 2. And this is the completed reduced row echelon form, and it solves problem 4. If you also want to notice, these are the x and y values. This is x, and this is y. That's because in the problem, this right here is x, this right here is y. That's a really bad y. There we go. Moving on to question 5. Things change a lot. I actually have to look at my notes for this because it was kind of complicated. Okay, so we're given 2 matrices. You can do every question on this test without a calculator, by the way, I'm pretty sure. I didn't use a calculator other than like the petty problems, like a big number subtracted by a big number. So people with the TI-83s or TI-30s are chilling. The first matrix, it's -1, -4, 0, 6, 5, 3, and he wants us to multiply it by a 2 by 2, 2, 3, 0, 9. And right away, I needed to find some of the parameters of the matrices. Going left to right is a row. Going top to bottom is a column. I don't know if I spelled column right. This mouse is a little too imprecise to spell column properly. In order to multiply matrices together, like there are some matrices you just can't multiply together. You have to do a column times row multiply. This is one matrice multiplied by a row times column. Okay, I'm actually really lying there. It's the exact same thing, column times row. And these two numbers have to match. And then these two numbers define the new parameters of the matrice. So, I'm gonna just draw matrice 2 there. Now that we've got that out of the way, let's start to get the framework set. Let's get a brand new color as well. Starting off, our first matrices parameters. The column, it's 3 down. 1, 2, 3. So that's going to make it a 3 by 2 because it's rows. And that's the matrice. Multiply it by the next column, which is just going to be 2 times 2. I mean, you really kind of have to try to mess that up, to be honest. And that's going to give us our new parameters. Since these two numbers match, it's a legal trade. And then these two numbers define the new parameters. So we're going to make it a 3 by 2 matrix. And we're chilling there now. So I'm going to scroll down a bit because I'm not very good with the handwriting and the mouse. Now it's time to introduce a new rule about multiplying matrices. in order to get like all those numbers he was like just spilling on the board Tuesday, you multiply row by column. And so I think is there a select tool on this? Rectangular select. Wonderful. You're coming with me. Oh, it didn't do anything. Wait, do I have to click it in order to select it? Maybe because it's a background layer. I don't know. Anyways, because I just have to copy this down again. So I'm going to write these really small. So we have negative 1, negative 4, 0, 6, 5, and 3. And then multiplied 2, 0, 3, 9. Multiply row by column. So, since we know, I'm going to make this a super big matrix because I need the room. We're going to multiply our first row. So all these numbers are going to be from the first row. And then by this column. So I'm just going to start out with an example. The first one is going to be from the first row. And then the first part of the column, or the first column on the second matrix. So the first row of the first matrix, and then the first row of the first column of the second matrix. So it's going to be negative 1 times 2, because first row, first column, and then we're going to add on the second part of the first row, which is 6, and then the second part of the second, wait, I might be tripping here. Oh no, okay, we're not. We're chilling. It's going to be plus 6, the second part of the column, which is going to be 0. I explained that really poorly, so you're going to have to bear with me on this. Negative 1 is the first part of this row, and then 2 is the first part of this column, 6 is the second part of this row, and 0 is the second part of this column. Since I'm going to divide these right now. So it looks something like this. This will be considered to be row 2, column 1. This will be row 3, column 1. This will be row 1, column 2. And then this will be row 2, column 2. Row 3, column 2. So let's move down to row 2, column 1. We're going to borrow the first number from row 2 in the first matrix, negative 4. Multiply it by the column 1 first number, which is going to be 2. We're going to add that to the second result of row 2, which is 5. So 5 plus the second result of column 1, which is 0. And then I think I can actually just add the results here now. This is going to equal negative 2. This is going to equal negative 8. Let's move down again. Row 3. What's the first result of row 3? 0. So we're going to make that 0. What's the first result of column 1? 2. So we're going to make that a 2. Add that on to the second result of row 3, which is 3. So bracket it out, 3. And we're going to multiply that by the second result of column 1, which, fun fact of the day, is going to be 0, which leaves this matrix at 0. And that's the right answer. Moving on to this right side now, row 1, column 2. We're going to start out with row 1, which is 1, or negative 1. And we're going to multiply that by the first result of column 2, which is now 3. Multiply that by 3. We're going to add on to the equation with the second set of results, which is going to be 6 of row 1, multiplied by the second result of column 2, which is 9. Funny jokes. And that's going to result in 51 being the answer. The second thing, row 2, column 2, we're going to start out with negative 4, because negative 4 is row 2 of the first matrix. We're going to multiply that by the first result of column 2, which is 3. I'm still doing this right. I am. We're going to add that to the second result of row 2, which is 5. And then we're going to multiply that by the second result of column 2, which is 9. And that's going to be giving us 33. And then lastly, you've made it this far. I hope it's made adequate sense. Row 3, column 2. This is the third row right here. So we're going to start out with 0 multiplied by 0. Wait, I'm a big liar. I'm sorry if I just confused you. It's the first result of column 2, which is 3. Add that on to the second result of row 3, which is 3 multiplied by the second result of column 2, which is 9. And this leaves us with 27. You can do the math on that one. And that is the entirety of matrix multiplication. This is probably as hard as it gets. I'm going to be fully a dead ass. I can't swear it's going to get taken down. This is tragic. I hope it doesn't. Do I have any room left on here? Okay. No, I don't. I need to clear this all. Is there a way to clear this? Whoa, sorry if I just broke someone's eyes. That should probably be really funny. Fill, make it black, paint it black. Rolling Stones, is that you? Okay. Let's scroll to the top. Question 6. That's in black. Hold on. Question 6. This is the single factors. We have to show the decomposition of 1 over x squared minus 1. There are 2 ways to do this problem. I'm going to do the cooler way first because I think it's cooler. We're going to start out by breaking this problem apart by making this 1x squared minus 1 equal to a over, and we can factor this out. We can factor out x squared minus 1 into x minus 1, and plus b of x plus 1. And then these two terms together would be x squared minus 1. I don't know where the a and b's come from. You're just going to put them on the test at the top, and you're going to solve the problem. In order to get rid of this x squared minus 1 out of the denominator, we're going to multiply this whole equation by x squared minus 1. That will just send this to Valhalla or Helheim. I don't know which one. I'm such a fucking nerd. Oh, okay. That will give us 1. It's equal to, I forgot to say, since this is x squared minus 1, we can essentially also just break this apart into x minus 1, x plus 1. That'll cancel out one of these terms from each of these. So for a, it'd cancel out x minus 1 and just leave it with a x plus 1 on the top. And then for b, it'd cancel out the x plus 1 and leave x minus 1 on top. So I'm going to undo that real quickly. So now we have red, the red color, 1 is equal to a, x plus 1, because x minus 1 got canceled out, plus b, x minus 1, because this x plus 1 got canceled out. From here, I gotta check what happens in the work. Okay, we can set x to whatever we like. So in this case, we're gonna set x equal to -1 in order to eliminate the a variable, because if x is equal to -1, that kills a and just leaves b for solving. So that's exactly what we're gonna do. 1 is equal to a, -1, because that's our new x value, plus 1 plus b, -1 minus 1, which is equal to 2. Now we're left with a, or 1, because this a term cancels out completely. 1 is equal to b, -2. Or if you're a proper person, you're going to transpose that to 1 is equal to -2b. From here, it's pretty simple algebra. Just divide both sides by -2, and you're left with b is equal to -1/2. And then you can do this the other way for a, which I'm gonna just let me just erase all my work real quickly. Is that too far? No, it's not. Okay. We're now going to make b equal to 1 to get rid of the b value. So that just kills the b value because 1 minus 1 is equal to 0. So goodbye b. And now we're going to be left with 1 plus 1 equal to 2. It's going to leave us with 2a equal to 1. 1/2 equals a. And then if we take the previous result, -1/2 equals to b. This is our solution to the problem. The other way, which I recommend you do, because he seemed like he wanted you to do it this way, it's also kind of fun. You're also going to have to use it for the next problem anyways. What you do from here is you expand the terms. So you do 1 is equal to a of x plus a plus b of x minus b, because b times -1 is equal to -b. And then you group the like terms. So we're going to have a plus b in x. I'm going to get a new color after this because this is actually looking pretty bad. So a plus b in brackets x to get rid of these that's not the same. Okay. Not going to change colors? Okay. Get rid of ax and bx, group those together. And then we're going to add on a minus b to get rid of a and then -b. And now these terms are grouped together. We're going to get a super cool new rule added to the mix. We're going to do 1 plus 0x is equal to this. And essentially, I'm going to flip to my notebook page so I can get my explanation out. Essentially what this does is it, where is it? Allows you to make x equal to 0 right away. So what we're going to do is, since we know x applied to both these terms is going to equal 0 no matter what, we can just safely cross this out since the 0x is equal to 0, get rid of that. And now we're going to be left with 1 is equal to a minus b. And there's so much stuff you can do to play around with this equation. The way I played around with it is I made 1 plus b equal to a, I think. Let's see here, where did I do this? Oh, no, 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 no. I made a very big mistake. I'm sorry, I just wasted the last 5 seconds of your life. We do not cross out a plus b. Instead, we recognize that a plus b is going to be equal to 0 because x times a plus b is equal to this 0 right here. So we have a like a fun little rule we can play around with here. And now that we know that's possible, we now know that 1 is equal to a minus b. We can now figure out what a and b are. So to start out, I'm going to start by solving for a. What I'm going to do, I'm going to make, from this, I'm going to make a new color for this actually. Let's pick green. I'm going to make a is equal to negative b from this equation right here. And then if we bring it over to here, we'll see negative b, well, that's equal to a. So we're going to have 1 is equal to a plus a. And that's going to be 2a. Divide it by 2 on both sides. We'll get a is equal to 1 halves. And then you can do this for b as well. We can make b equal to negative a. Is that what I did? No, no, I actually just reversed it. So instead of plugging in a here, I plugged in negative b for a. Crank out the yellow finally. Since a is equal to negative b, we can do negative b minus b is equal to 1 from this equation. The a is equal to negative b. And that'll give us negative 2b is equal to 1. That'll give us negative 1 halves is equal to b. And that is the answer to problem 6. Problem 7 now. It's where things get extremely unfun and unfunny. Draw out question 7. This is called a partial fraction. We have to show the decomposition of 3x over x minus 3 squared. And essentially, the way we start out by doing this is we write it equal to the a, b terms. So we have 3x minus 3 squared is equal to a plus b. But here's where a new rule drops. Whenever the entire equation like is in bracket, or like the entire denominator is squared, you just keep that equation and move it up a square. Essentially, I'm gonna get a whole new color. Do I even have any new colors? I'm gonna pull out teal. Hypothetical color. If I had like 1 over x minus 1 and cubed it, it would be equal to a plus b plus c. But instead of factoring it out, I'd have x minus 1 squared, and then x minus 1 cubed. So whenever it's in a parentheses, it's going to just go up in terms for every exponent number. I can now get rid of the teal. The hypotheticals are over. That's just to help explain what you're about to witness. So here, it's just going to be x minus 3 and x minus 3 squared, because that's what's the brackets rounded to 2, so it just goes to a and b. Which makes it thankfully a lot easier for us to solve, because now we're going to multiply the entire equation by x minus 3 squared. And that gets rid of this, and since x minus 3 squared is essentially just x minus 3 times x minus 3, it get rid of this and just adds on another x minus 3 up here. So essentially our new equation is going to be 3x is equal to a x minus 3 plus b. And now super sick rule, or not a super sick rule, I almost stop speaking, my bad. We're gonna add the 0 to this. The 0 from, let's see here, where was it? Was it up here? The 0 right here is gonna get added down here. So 3x plus 0 is equal to a x minus 3a plus b. And since we now have the 3x and the 0, we now know what we want to solve for. So I'm going to use a teal color a lot more often now because that actually looks pretty nice. We have this, and then we have this. Actually, I'm going to underline them. This and this. Um, we want to solve for x. So how do we make 3x equal to ax? Well, it's really simple. Just make a equal to 3, and now we have 3x. And that's literally the answer. A is equal to 3. But we want to solve for this equation now. How do we do that? Well, we know that a is equal to 3, so this part, where's it? Green. This part right here is equal to negative 9. And over here, this is equal to 0. We want to make the non-x values equal to 0. So we have to make b positive 9 in order to make this term right here true, equal to 0. So that makes b equal to 9. And I didn't intentionally use Christmas colors, but that's how we're going to go. That's the answer. Just remember to add the zeros and separate the terms to make them true, and you'll probably be able to get through question 7 pretty easily. Oh, it's just like an unfortunate little smidge. Okay. Question 8. Question 8. That's in French. For all you Frenchers out there. We have y is equal, or greater than or equal to x squared, and then x squared plus y squared is equal to 2. This is a graphing problem, so I'm going to draw a big, beautiful graph. The first thing you need to recognize, first thing you should know about this, you can treat these as equal signs for the first part, and just use this as graphs. So if we treat this as y is equal to x squared, fun fact, that's just a parabola. Looks like that. And then x squared plus y squared is greater than 2. I'm going to go to Desmos for this one, because I feel like that makes it the easiest to explain. Wait. If we just have y squared is equal to x, this is what a y parabola looks like. On the 2 problems provided, like on the practice test, it goes out this way. Actually, I should probably get another piece of paper. Or probably get a different color. It goes out like this, from like -2 or whatever. That's a negative y squared. does not fit our definition. Instead, for the people who are having the luxury of a TI-84, you can just plug this equation in to your calculator, and you'll figure out that it's this. For the people who don't have the luxury, what you can do is you can square the whole equation. Where am I even going with this? I have no idea. I feel like the only dead giveaway, because I really don't know how to explain this problem very well. I'm not gonna lie. It's just to recognize this is a parabola. It's like a normal parabola. And if you see two options and one's a parabola, you'd be like, wow, this is it. Um, Getting off the sidetrack though, and my ignorance, where do these less than or greater than symbols come in? Well, it comes in for the shading section of the problems. So essentially, whenever you have these, it's like a certain area that you can shade on the graph. For y is greater than x squared, means y is going upwards. So right here, we have y going upwards. And it's going to go like that until infinity. And that's like just the dead giveaway on the graph. Like you should be able to instantly like ascertain that's like, wow, that's the answer. Um, but anyways, when it's less than, for instance, let's say y was less than or equal to, well then it would look like this. And that would look really bad on my test. So good eye. That was a complete train wreck of an answer. I was not prepared for that. I'm not gonna lie. It just feels easy enough to solve. Question 9. The inverse matrix. This one's pretty cool. It's a lot of matrix writing, which isn't the funnest. We have A, matrix A, which is equal to 1, negative 2, negative 3, 2. And then we have to figure out, we have to write the doubly augmented matrix and then get it into an REF, which is a reduced row echelon formation. That's where it's like 1, 1, 0, 0. That's what it wants to look like. And we have to use it for the inverse. Essentially, what that looks like is it's going to be A is equal to I. We're combining two matrices here. Matrix A and matrix I. What matrix I is called the inverse. Matrix I is always going to be equal to a like same number, so it's gonna be like an x, or not an x, but a y by y. So for instance, a 2 by 2, it look like this, or maybe a 3 by 3, where it would look like this. In this case, it's a 2 by 2 because this is also a 2 by 2, and it seems convenient. So we're gonna combine these two problems up here into the AI. It says this for the it says this on the paper, like do an AI, and what that looks like. So we're gonna take matrix A, 1, negative 2, 2, negative 3, add these cool little colon dots, and do our inverse matrix. And essentially, what you have to do for this problem is just flip these things across the dots. So I want 1, 0, 0, 1 over here, and then the other side, like this part right here, doesn't really matter what happens to it, as long as I get 1, 0, 0, 1 on the left side of the dots. So let's begin. In order to get the bottom row situated like almost right away, or I think it actually does get situated right away, we're gonna do row 2, the row we want to modify, minus 2 row 1. What that does is we're going to take row 2, minus it by 2, row 1. So negative 2 times 1, negative 2. Crunch that number together. It's going to give us a 0. Oh no. It's what we want. And we're going to take row 2 minus 2a, 1, or 2 row 1. Negative 2 times negative 2 is equal to 4. Or negative, yeah, it's just equal to 4. 4, negative 3, crunch them together. That's going to give us 1. Holy cow. And then this side of the matrix, I'm not willing to explain. You can just put the numbers together. It's just going to be negative 2, 1. And then top row, well, it just stays the same. It's going to remain its same old dandy ways. So that's the first set done. I'm going to denote these as 1, 2. We're going to move down to 3 down here. So now what we're going to do, our next equation, is going to be row, where did I put this? We're going to do row 1, because that's the row we want to modify. This row right here to make this a 0. So we're going to do row 1 plus 2 row 2, because we just want to make this number right here a 2, crunch it into this negative 2, and make it a 0. And since this bottom left number is already a 0, you really can't change it by multiplying. So we go here, row 1 modified, this is going to remain a 1, 2 times 2, or 2 times 1 is equal to 2, crunch it in, it's a 0. And that completes the row echelon, reduced row echelon, because it's the 1, 0, 0, 1. And then we have to solve for this other side, which I'll actually do, because I'm feeling a little generous. Negative 2 times 2, put that into here, it's negative 4 plus 1, negative 3. And then 2 times 1 is 2. Throw that up here. It's going to be 2, because 2 plus 0 is equal to 2. And then since this bottom row doesn't change, it's like that. This, I believe, is the final answer. It's correct. Identifying the inverse matrix is either this, 'cause I actually don't know what an inverse matrix is, or it's just this right side. So it can either be that, or it can just be negative 3, negative 2, 2, 1. And this isn't the actual same matrix. The first one is just like slightly changed around. So yeah, that's question 9. Moving on to the grand finale, question 10. It's actually a lot easier than I thought it would be to explain, which I'm really happy because I'm kind of wanting to go to bed. So we're going to write out what he's given to us. 5x plus 9y is equal to negative 14. And then 3x minus 7y is equal to 10. And we have to use Kramer's rule. That sounds weird and scary. It's really not that hard though. There's just a lot of matrix writing involved. So to start, I'm going to grab a bright color. Let's use yellow actually. And let's start by writing out what we need. We need determinant. Let's see, where's my work here? Determinant, or just d, dx, and dy. That's really all we need from this problem, because these will give us x, y, whatever we need. So in order to get dx, what you do is we're going to write a 2 by, I'm actually, we're going to write a 2 by 2 matrix, just consisting of these variables. So it's going to be 5 3, 9, -7. In order to get the determinant of these variables, we're going to do a slick mathematical equation. Um, we're going to do 5 times -7 minus 9 times 3. Now, bear with me for a very quick second. The way it works, you do this times this for 2 by 2s. For 3 by 3s, it's a lot longer. And if you don't have a calculator, you're probably getting it wrong. So that's essentially this. You'll take the A1 times B1 or B2 and subtract that from A2 times B1, and that's D. What this will, and once you multiply this together, I believe you just get 8, which is equal to just the determinant, or D. Now to get dx, I should clarify that this is the x and this is the y. You make sure there are no like x values. So 5 and 3, x values cannot be present in the dx or the determinant of x. So how do I complete my 2 by 2 matrix? Well, you borrow these values and just slot them in for the x. It's going to be -14, 10, 9, -7. No x values present. Everything but the x values. And then you do the exact same thing. You do the A1 times B2. Subtract that from A2 minus B1. Where's the work on here? I think this is, that's the way, it's not 38, it's 98 minus 90, which is equal to 8. Holy moly, we did it. Now for dy, we cannot have any y values present in this 2 by 2. So what do? We add back our x values, and then we banish the y values. So we have -14 here, 10 here. You're going to do the exact same thing by grabbing the A1, B2, or minus the A2, B1. I'm losing my voice from this, which will end up getting you -50 minus minus, which just turns that into a plus 42, which is equal to -8. So this is this top one is D. This second one is the determinant of x. And lastly, this bottom one is the determinant of y. I have a little bit of extra notes on the next page, so I need to scroll over to make sure I've got everything. In order to get the x and y values, like in order to get x and y from this like original equation, I know we've gone so far without it, it's kind of weird. In order to get x, we do the derivative of x over, or not the derivative, but the determinant of x over the determinant. So in this case, it's going to be 8 divided by 8, which makes x equal to 1. Holy cow! That's so cool. In order to get y, well, I should probably get a different color. In order to get y, take the determinant of y divided by the determinant, which gets you -1, because we have -8 divided by 8, which gets you -1. That's your x and y value. It's kind of crazy. That's the entire thing. Personally, I will be acing the test per usual. Good luck to you.